Good day, Madam Nurliyana. Today, we like to present about assignment Basic Electronic BEEC 1303. Okay, we are from BEEC Section 1, Group 1. Our group contains 4 people, including me. First, our group leader is Muhammad Nazrul, ISKANDAR, and followed by Muhammad HAMIZAN, and SITI NURHIDAYAH, and myself, Roobakkanthan. Okay, the topic we get for the assignment is about common emitter amplifier. The common emitter amplifier is a voltage amplifier that consists of 3 basic single-stage bipolar junction transistors. This amplifier's input is taken from the base terminal, its output is collected from the collector terminal, and the emitter terminal is shared by both terminals. Next slide is presented by Muhammad Nazrul.
Okay, Assalamualaikum warahmatullahi wabarakatuh and good evening. So my name is Muhammad Nazrul Iskandar bin Muhammad Nazarudin. Okay, so here we got the voltage divider circuit BJT. Okay, the first thing is the first thing to calculate this voltage divider is to find the IB which is current at base. So the formula that we are using is 2 IC over with beta, which is beta. I already choose the value. As we know that beta, the minimum for beta is 100, to the maximum is to the maximum is 300 for beta value. So here I use for beta I use 150. So the formula is IC, current that go through RC, which is IC. I got 2 milliampere on the left sheet. So 2 milliampere over with the beta, which is 150. So I got so we got here is 12.509 microampere. And then secondly is we need to find the VB, which is the voltage, the voltage across the base. So the formula is VB equal to VE, which is the current through VE, current through the VE plus with VBE. So I assume that the voltage at VE is 1.5 volt, then plus with VBE. So I got 2.2 volt over here, 2.2. So the next step is to find the R2 first. R2. So the formula is voltage at base over with 10, which is 10% of the resistor, times with 13.3, or here at simulation 12.519 microampere. So we got this resistor 16.5k ohm. So after that we need to find the R1 value, which is here 190k ohm. So from that we use the formula is VCC minus with VB, minus with the voltage at base over with 11 times with 13.3 microampere, or here estimation is 12.509 microampere. So from that formula I got 190 kilo ohms. The value for R1 resistor. And then so the next step is the step 5. We need to find the I over I current through RE, current through resistor RE. So the formula is IC, current that go through RC plus with current that go through from IB. So because so the formula is plus IC plus with IB. Why? Because the current go through the same node, right here. So uh, so IC we got from the lecture is 2 milliampere plus with the beta 12.509 microampere. So we got um, 2 so here for the IE I got 2 milliampere, which is here from the calculation is 2 milliampere, but from this simulation I got 1.8889 milliampere. So after we find IE, we can start to find the value for RE, which is here on the simulation is 750 ohm. So by using Ohm's law, is R equal to V over with I. Uh, so voltage at VB voltage at base, which is we already know 2.2 over with current, which is current at IE, we already know which is 2 milliampere. So 1.5 over with 1.5 from the calculation over with the current that goes through IE, which is 2 milliampere. So and then we got the value for the resistor for RE 750. So after that, the final step is to find the value for RC from here, which is the answer is 1 kilo ohms. So how to find it? By using Ohm's law, Ohm's law, the VCC minus with VE, voltage that flow in the emitter, over and then over with IC, which is we already know is 2 milliampere. So VCC is 30 minus with 1.5. Sorry, VC with okay for VC I got from the 1 over 2 times with this 30, so we got 15 volt. So VCC is 30 minus with VC, which is 15 voltage, 15 volt, over with IC is 2 milliampere. So here I got 1 kilo ohm.
My name is HAMIZAN. This is different between simulation result and calculation result. For the calculation result for IB is 30.3 microampere. For the simulation result, IB equal to IC per beta. We put 150 for beta. IC is 1.8764 milliampere and divide by beta 150 equal to 12.509 microampere. For the calculation, VB result is 2.2 volt. For the simulation, VB equal to VE plus VBE. VE is 1.4167 volt plus VBE. VBE is 0.79049 volt equal to 2.2072 volt. For the calculation, IE result is 2.0133 milliampere. For the simulation, IE equal to IC plus IB. IC is 1.8764 milliampere, and for the IB is 12.509 microampere equal to 1.8889 milliampere. For the calculation, VE result is 1.51 volt, and for the simulation, IE is 1.8889 milliampere, and times multiply by 750 ohms equal to 1.4167 volt.
Assalamualaikum warahmatullahi wabarakatuh. And hi, my name is SITI NURHIDAYAH binti NAZARUDIN, matrix number B08211039. Basic operation of the BGT. When electron flow through a forward bias direct junction, such as the base emitter junction of a transistor, it actually takes a non-zero amount of time for them to recombine with hole on the P side and be neutralized. In an NPN transistor, the P-type base region is constructed so as to be so narrow that most of the electrons actually pass all of the way to it before this recombination occurs. Once they reach the depletion region of the reverse bias base collector junction, which has a strong electrical field across it, they are actually swept away from the base region altogether, creating the collector current. The total current through the base emitter junction is controlled by the base emitter voltage, which is independent of the collector voltage. The circuit function. The basic function of a BGT is typically to function as a switch or to amplify, filter and rectify power. Bipolar transistor are current controller and operator device, meaning that a much smaller base current causes a larger current to flow from emitter to collector. Characteristic of the BGT. First, they can take a low input current and use it to output a much larger one. Second, whereas mechanical switch always need a actuator to be physically moved to function, the binary on or off state of a transistor switch are instead voltage controlled at the base configurator. Unlike mechanical switches, they can be controlled by PWM, pulse width modulation signal. Transistor switch do not suffer from any physical bounce, unlike mechanical version.
In a nutshell, we have seen how does a common emitter amplifier's configuration behave. We have seen afterwards the architecture of the full circuit of CEA by understanding the role of bias and load resistor and coupling and decoupling capacitor. The common emitter amplifier presents high voltage and current gains that are enhanced by the presence of a derivation capacitance in the emitter branch. It also presents high input and output impedance, making it suitable as a universal amplifier for many applications. Between the input and output signal, the base of the transistor used in a common emitter amplifier is biased using two resistors as a potential divider network. This type of biasing arrangement is commonly used in the design of bipolar transistor amplifier circuits and greatly reduce the effects of varying beta by holding the base bias at the constant steady voltage. This type of bias produce the greatest stability. Thank you.